doctors, that's just coming over their speakers, that's why you're hearing yourself.
Alright, so once we've got the wire here, remember the central port here is the action port, I like to call it. We drop down the guide and make sure that our wire is actually in the central lumen, which it is. Once we confirm that, close that out. And now the robot is engaged and the wire is ready to be manipulated from the arm.
All right, Alan, can you come back here? So let's switch to the robotic view. So this is the part I like about doing angioplasty. You can sit back and take a look at, I have access to the hemodynamics and the angiographic view. And over here on the left side, I control the balloon and stent. And on the right is the guide wire. So I'll enable the robotic system. And here with my left thumb, you can see that that's what we call the turbo boost. So you can get the wire down relatively quickly. So now the wire's down, I'm advancing the balloon.
There's no balloon.
There's no balloon on this wire, we're just with wire.
Oh, this is the first LED wire. Give me a puff, guys. You can see that went into the circumflex. And that now has gotten us into the LED. So we're switching to the cranial view. Okay, give me a puff there, guys. So I just moved the wire back. So that's gotten us down the LED, which we'll take. And now what we're going to do is take the second wire, load it up on a balloon, and we'll advance that wire and balloon to the diagonal. So let's go back to the table side.
Okay, so are you with me? All right, here we go. So again, anytime we want to go into the system, we have to ask the permission here. Once we get the okay, flashing green light. Okay to open up. What we want to do here is drop this wire down. So it's interesting because you can use the RX system here with the just like an over-the-wire system with the robot. So we've got the wire and the balloon loaded here together, and we're going to advance both of them together.
So Shemi.
So Shemi, I understand your strategy here is to pre-dilate the diag. Are you planning to stent it as well, or just to dilate it with the balloon before treating the LED?
Well, Gira, what do you think? What would you do?
I would do exactly the same. I think as Mike said, the diag is a moderate size. It has diffuse disease. Probably if we can go along just by dilating a balloon without creating a dissection, I would treat the LED provisional. I think what's nice that you're going to show us now that this diag that may look easy to wire, probably is not an easy way to wire it because also of the diffuse disease. And I think this is kind of an example that may show us that wiring side punches with the robotic system may be easier than manual.
You know, it's interesting you say that I find the same, that the back end of the wire, because it is locked up, you can rotate a little better.
And then you have an overall better stability, including the guide and including the other wire that is already located in the distal LED.
Right. So now,
So Shemi, how are you controlling also the fluoro? Do you have pedals that you control, or is your assistant doing that?
no, I've got the full control, including the fluoro.
So that's under the table where you sit.
Correct. So,
Do you miss the heavy lead apron?
I miss the heavy lead. I miss standing for 2 hours.
Do you ask everybody to turn on the heat in the cabin?
Can you give a puff, please?
Wow, you're amazing.
Just like Giora pointed out, we're in the diagonal already.
It's like, I blinked and I missed it.
And now we have a balloon across it. Puff that. So we're going to dilate from right about here. Slowly go up, guys.
2,
4, 6,
6,
8,
8,
and down.
8 and down.
Let's go up again.
What is the size of this balloon?
This is a 2,
So this is a 2015 Euphora.
8 atmospheres,
Okay, go to 10, 12.
12. 12 and down.
Mike, do you agree with this strategy?
If you could press the button while you're talking and then off.
Yeah.
That's
Go up
that's
one more
exactly
time,
what I
guys.
did. And very nicely wired that. That was slick.
8, 10, 12,
And down.
down.
Jamie, can you comment on wire choice? I've noticed there's several proprietary wires that work a little better with the robot, and that may just be luck or whatever, but do you have any preference for wire choice?
Yeah, so Mike, I would say I do 90% of my cases with the BMW. And it's hard to teach an old dog new tricks. So that's what I end up doing with the robot as well.
I think the other
Let's see, guys.
The other point is that the feel is all different. You don't have the feel anymore, and so you have to actually learn how to wire with the robot. It's very different. One comment.
I completely agree. So why don't you tell us about that, Mike?
So you don't have the feel. There's no tactile sense anymore with the robot, and the way you steer, the way you turn the torquing device manually is very different than it is with the robot. So you have to learn that, and it probably takes 10 to 20 cases before you get the kind of sense of how much you turn robotically and how is that going to translate to the tip. And the same with moving and moving and turning, all that stuff. It's a different skill set. So I think new operators get a little frustrated because they're used to wiring it manually, and it'll take you 3 seconds to wire it manually, and it'll take you, a minute to wire it robotically until you learn how the wire works in the robot. So that's a different skill set, and I think that's probably the one step that is going to take a little effort on the operator's part to learn the robotic system. The balloon stent part is easy.
Right. So at this point, what we've already done is dilated the diagonal. We're going to switch the wires. And so now we're going to take the pre-dialed balloon over the LED wire. Following that, we'll obviously stent it.
So I mean, how do you handle the 2 wires? So you have 2 wires, you control both or one at a time, or how does it work?
All right, guys, let's get that 2015 over the LED wire. And let's switch wires. So you can do bifurcation lesions, but you often need to work back and forth by switching the wires in the robotic drive. What do you think about that, Giora? Is that a limitation?
It's not a big one. now in the days of provisional bifurcation stenting era, that's I think 90+% of our bifurcation we treat provisional. There's no need to handle two stents like 10 years ago when we used to do some two stenting bifurcations. So it's not a big deal. As you see now that it's being parked on the side, and then the diagonal stuff, and now you're going to work on the LAD. It is very simple. Now the rest of the case, basically you will do the LAD, and the diagonal is there just to preserve and protect the diagonal.
Mark?
So here, let's go to Alan's camera. And I just went ahead and activated the robot again. And my left index finger is on the, what we call the turbo boost. Okay guys, dilate that.
2, 4,
6, 8, 10, 12.
6, 8, 10, and 12.
And down and pull the diag wire a little bit. Let's go up again.
2, 4, 6, 8, 10, and 12.
And down.
Down.
So in this case, you're pulling the diag wire manually.
One more up.
Yeah.
I'm sorry, go ahead.
You're pulling the diag wire manually, not robotically in this case.
Correct, Ori, because you can only control one wire with a robot. But that's a key point. So in essence, at this point, we've done our pre-dilation, we're ready to stent.
Second marker.
Okay guys, take a puff. Great, we'll take a 275/30 resolute. Anybody on the panel, there's a particular stent choice to preserve side branches?
I think now all the second, third generation stents are all good, are all basically not hurting many of our side branches. I don't see any difference between them. I don't know, Manos.
No, I agree. I wouldn't. I think whatever you have. Are you going to jail some? Are you going to jail the wire in the diagonal, or are you going to pull it back, or?
So I was planning to jail it and then take an angio, and if it's patent, then pull it in.
Are we live here for?
What do you think?
No, I agree. I think always routinely jail it and usually go low pressure, 10, 12, 14, and then take it out and go to 20 afterwards. And that works pretty well most of the time. I think BMW would be okay. If it was a polymer wire, I'd be a little more skeptical. If it was a Whisper or a Fielder FC, but I think with the BMW, it should be fine.
Perfect. Can we look, and let's go table side, Alan. And so Alan's going to show our loading up of the stent.
Okay, well, we're quite fast here, so the stent's already loaded. Basically, you can see I've maintained placement of which wire is which by using this back port here. It's quite easy. Make a little indentation with a blade, and then you can actually insert the wire into it, and it serves as a holding place. Also allows you to not confuse your wires. So now I've got the stent balloon and stent loaded on the central core wire, which is our LAD wire. And as I drop this down, I'm going to make sure that this side wire, which is the diag wire, goes on the side port. And then our stent is in this port. And we put the wire center. Everything's lined up. Just close. And we're locked and loaded.
All right, Alan, let's come back here. So once again, you can see what it looks like. So we've got the balloon, guide wire, and the ability to enable it here. So once you enable, you now have control of the robot. and my left index finger will advance the stent much faster. That's the turbo. And you can see the stents coming down and across the lesion here. Go ahead, give a puff, guys. A better puff. These guys didn't have breakfast, they had to come to the meeting early. All right, go ahead, dilate.
It's a nice demonstration how everything looks so stable, both wires and the guide. You see, nothing has moved because the system holds them.
2,
It's
4,
actually giving you additional
6,
hands while you do the
8,
advanced stent.
9,
12.
10, and 12.
So
And down.
doing that,
12 stent
what is the
deployed.
advantage that you see?
So
over
we
doing
deployed the
this
first stent,
versus manually? Right,
and
you
you can
still
see it's a
have
30
operations.
millimeter length stent, and no
I'll
problem.
do something to
getting
my
across.
top later on. But basically, you see there that's the Shemi how relaxed he is. He can concentrate on making the decisions, not on the technical stuff. The technical stuff becomes so easy. He's being protected from radiation. I think the guy that worked the hardest in the cath lab was the cameraman that walking around back and forth. But basically, they see the operators doing the procedure that is being protected from radiation, and technically, the system is so stable that you can do complex bifurcations basically in a very safe way.
So the next thing I want to do is go ahead and take the diag wire out.
I think the other point there,
And so as Manos pointed out, this is what we would do manually. You can see the BMW came out without a problem.
the visualization. So Shami's is sitting there and he has the screen inches from his face and he can see, like we can see here. Whereas when you're the operator, you're looking across the room, you're straining to see, and that's a big advantage, especially for very precise placement.
Geographic miss.
Yeah, and it's really nice to have that screen just inches from your face and be able to really position equipment, steps, balloons exactly where you want it.
Give me a puff, guys.
And that's without having
You
to
can see
lean
that the
forward and
diag is
expose your
big.
head to all that radiation.
All right, guys, go up a little higher. 2, 4, 6, 8, 10, 12, 14, 16,
16,
18, and down.
18. Down.
So the next thing I want to highlight is how you can measure the length of the lesion to figure out the next stent we need to place. So I'll quickly do it, and Giora, maybe you can talk about it. So we're here at the distal stent. Hopefully you can see with my finger. And then if we look at the robot here, we can get precise millimeter by millimeter length. And so you see, I moved the balloon from the distal to the proximal, and that's a 30 millimeter stent, and it measures at 30.1 millimeters. So guys, let's come coddle. We're going to use this to figure out our second stent length. So I'm going to re-zero, and give me a puff.
Neocolonies.
So as we bring the balloon back, right about here, puff again. That's where we want the stent to edge. Sorry, the end, and it measures at 21 millimeters. So as a result, I'm going to pick a 22 millimeter stent.
Mark.
Guys, let's give a little nitro and an angio. Gary, you want to talk about the lesion measurement?
I think this is an important feature of the robotic system that is in advance and to optimize our procedure. Because what we usually do, we either eyeball the length of the lesion, or we use the pre-dilatation balloon to estimate the length. Sometimes it moves. And we all know that as good as we are, this is not perfect. It's only an estimation. We suffer from different angulation and foreshortening. And it's really measurement from the inside really can give us the real length, as you showed that you demonstrated very nice with measuring the length of the stent, and that this measurement is very accurate, and it can save us using unnecessary additional stents, because if you would estimate that is something like now 17 millimeters, you would take an 18 millimeter stent, you would miss the length, then you would need a third stent, and that can make a big difference. It's also an economical thing that's basically, and we know that from previous series that between 10 and 20% of the cases end up with unnecessary stent just because of underestimation of the length of the lesion.
All right, so does
If I can
everybody
say-
agree with a 275 22 length stent? And it's probably a 3.0 in the Prox LAD, but I'm a little concerned about the osteoarthrosclerosis, so we'll post Bill with a bigger balloon. 275 22 Resolute.
So if I can say from perspective, someone doesn't use the robot yet. Actually, this is a key component because, as Gary was saying, we often, like for me, I always, if I have a question, I'll get an extra balloon or something, or try to get a second balloon. So actually, you end up spending more money getting more equipment in to judge the length of the lesion. So having the option to measure it through the device, the robot, I mean, that makes it way, way much easier and safer.
And so as everyone can see, we've essentially dilated the diagonal. We've got our first long stent in the mid-LAD. This is our second stent, which will be our final stent. And once we've deployed it, we'll take an angiogram and figure out whether we need to post-dilate or not.
Shemi, I
You
see
guys want to
that.
see the stent being loaded, you can see it
Yeah,
here.
let's see putting the second stent. So let's go table side. Sorry, Gira, go ahead.
Sorry to interrupt. I see there on your table next to your joystick, I see another screen. Can you educate us what it is?
Yeah, so again, at this point, they've taken me away, but
Yeah.
this small screen next to the joystick is really there to, while I'm sitting here, I can see exactly what's happening at table side with respect to changing of equipment. And so we virtually can do most of our cases with very little talking back and forth, because I can see where things are at and move on to the next step.
So you're the big brother watching everybody.
Watching everybody through a camera that's set up at the foot of the bed, and just makes this idea. You could have this cockpit. We have it in our control, in our room itself, but there's nothing to stop us from putting it in the control room or anywhere else for that matter, because that second screen can help you. So once again, as you watch, I'm going to enable the core path system. Once I enable it, I now control it. It's no longer controlled table side. This, my index finger is going to control the speed with which the stent is advanced through the guide catheter. And the joystick, so now I take off the turbo so I can slowly bring it out of the guide catheter into the Prox LAD. Puff that, guys. So we are right about where we want to be. Puff again. So I'm happy with that. Let's go with Craney to make sure it's overlapped. So they changed the view. We look at it, puff that. Hopefully you can see this fluoro live at the meeting. And we're just overlapped, so we're happy with that. Let's go ahead and deploy.
Stent's being deployed.
So the Prox LAD stent being deployed, go to 6, 8, 10, 12, 14, 16, 18.
16 and 18.
And down.
Down.
So Giora, maybe while they're doing that, you can help the audience understand why the robot would actually be helping you do measurements.
Go ahead and dilate up. Go to 18, 20.
So,
20.
as I said before, in real life,
And down.
you have to choose the best view. You're not always able to take the best view to really open the whole length of the vessel. There's always some foreshortening. And if you measure it from the inside, you use the marker whether of the wire or marker of the balloon, and you just pull it from the distal end to the proximal end of the segment you're interested. You know the exact length unrelated to foreshortening.
So it's actually the pullback that, or moving forward, that gives you the measurements.
Yeah, you need to move something inside.